Welcome back, everyone, to NMcDonough Consulting's AI Bootcamp, Episode 2. I'm NMcDonough, and today we're going to dissect what powers AI, the engine behind the scenes, machine learning. Just to recap, in Episode 1, we explored what AI really is, demystified the jargon, and showed you how AI is already everywhere, from your phone to your business. We also introduced the three major types: predictive, generative, and automation AI, and why AI is about amplifying our human abilities, not replacing humans altogether. So now that the foundation is laid, we'll get practical. How does AI learn from all that data? How does it turn raw numbers into predictions and decisions that can transform how your business runs? Let's dive in. By the end of today's session, you'll understand what machine learning really means and how it works as the core of AI technology. You'll be able to explain the three main types: supervised learning, unsupervised learning, and reinforcement learning, along with real world business examples, so it's more than just theory. You'll also grasp why data quality matters. Not all data is equal. We'll walk through the typical machine learning workflow, showing how data gets transformed into insights. Lastly, you'll learn when machine learning is the right tool for your problems, and when a simpler approach might actually serve you better. My promise is that you'll finish this session equipped to spot real AI opportunities and lead with confidence. Let's start with a foundational difference: traditional programming versus machine learning. Traditional programming runs by explicit rules. If X happens, do Y. Every condition must be anticipated and coded. This is perfect for simple, predictable tasks, but cracks under any complexity or change. Machine learning turns this on its head. Instead of coding every step, we feed the system thousands or even millions of examples. The system studies those examples, uncovers hidden rules, and uses them to predict or classify new data. This shift from rule-based to data-driven learning is why AI works on everything from recommending products to diagnosing disease. Machine learning is essentially pattern recognition at scale. Remember learning as a kid that a red octagon means stop? The brain learned by repeated exposure to stop signs in different places and conditions. Machine learning algorithms do the same with data, except instead of a handful of examples, they can analyze millions. They mathematically measure relationships between variables and learn what combinations predict outcomes. It's not a traditional program with step-by-step instructions, but a flexible, evolving model getting smarter with every new piece of data. There are three distinct flavors of machine learning. First, supervised learning, where the system learns from labeled examples with known outputs. Think answers in the back of a textbook. Second, unsupervised learning, which finds patterns and structure in unlabeled data without predefined answers. Third, reinforcement learning, which learns through interaction, trying actions, getting rewards or penalties, and adapting over time. Each type addresses different business challenges, and knowing which you need is very critical. Supervised learning is the backbone for many AI applications. You provide the machine thousands of examples with known outcomes. For example, this email is spam, this one isn't. The AI learns to map input signals to outputs and then applies those insights to predict outcomes on new, unseen examples. It's powerful, widely used, and leverages historical data to predict future events. This approach works for many practical problems. Email spam detection learns from labeled emails to filter unwanted messages. Credit risk scoring relies on historical loan outcomes to predict default risks. Health AI trains on medical images labeled by doctors to identify conditions early. Supervised learning shines wherever you have clear historical data and need prediction. What about when you don't have labeled examples? That's where unsupervised learning comes in. Here, the AI explores raw data to find clusters, associations, or anomalies without guidance. It's like giving the machine a pile of data and asking, what natural groups or patterns do you see? This helps uncover hidden insights or relationships that nobody suspected. For example, retailers use unsupervised learning to identify new customer segments. Market basket analysis discovers which products sell together, helping with cross selling and promotions. In security, anomaly detection finds suspicious activities without prior labels, helping prevent fraud and attacks. Here's a quick challenge. A retailer wants to predict customers likely to buy next month with data about past purchases and known purchase outcomes. Which machine learning type fits best? Is it A, supervised, B, unsupervised, C, reinforcement, or D, none of these? The correct answer is A, supervised learning. Since you have data on your customers, including what they purchased, you can actually train the AI to predict which customers will purchase which goods. The third flavor, reinforcement learning, learns through trial and feedback. An AI agent interacts with an environment, trying actions and receiving rewards or penalties. It learns strategies to maximize reward, much like training a pet or playing a video game. This is key when the AI must make a sequence of decisions in a dynamic setting. Now, let's bring reinforcement learning to life with some real world examples you've probably encountered, even if you didn't realize it. First up is dynamic pricing. Imagine buying a plane ticket or ordering a rideshare. The price changes depending on demand, how many people want it, competitor prices, even the time of day. AI is constantly adjusting those prices in real time, learning what the market will bear and maximizing revenue while staying competitive. The reward the AI chases, bringing in more revenue without scaring off customers. Next, let's talk about recommendation engines. This is what powers those you might also like suggestions on Amazon or Netflix. The AI learns which recommendations actually get you to click, watch, or buy. Every time you interact, click, purchase, like, that's feedback. The AI tweaks future suggestions to engage you better, with the main reward being higher user interaction and, for businesses, more conversions and sales. Now, autonomous vehicles. Self driving cars don't just follow hard coded rules, they learn the best ways to drive by running through millions of simulated and real scenarios. Did the AI's decisions lead to a safe and smooth ride or not? Safe, efficient arrivals are the rewards that reinforce smart decisions, while risky moves are penalized. Lastly, trading algorithms. Here, AI dives into complex market conditions, testing different trading strategies to discover what yields the best outcome. The AI is always refining its approach, aiming for consistently profitable trades while managing risk, seeking the reward of sustained gains. So, the big idea in all these scenarios, the AI isn't just reacting, it's learning. Every win or mistake makes it smarter for the next time. Reinforcement learning is especially powerful in environments that move fast, have tons of variables, and reward continuous improvement. There's a secret sauce that decides AI success, and that's data. You need vast, clean, relevant, and recent data to train effective models. Without good data, even the smartest algorithms fail. So, data is the foundation, and investing in data quality delivers compounding returns. Good data is complete, consistent, current, relevant, and accurate. Bad data is incomplete, outdated, noisy, or biased. Poor data quality costs businesses billions of dollars annually in lost opportunities and bad decisions. You should always prioritize a data first strategy. For our next question, your AI model to predict customer churn is only getting 60% accuracy. What's the most likely cause? Is it A, the wrong machine learning algorithm? B, poor or insufficient training data? C, not enough computing resources? Or D, competitor interference? The answer? B, data quality is the most critical factor impacting accuracy. To build ML solutions that actually work, Follow this 6-step workflow. Number 1, you want to collect raw data. 2, you want to be able to clean and prepare the data. 3, based on your data, you want to select a suitable model. 4, you then want to train your model on your data. 5, and the most iterative step, is validating your outputs and tuning your model's performance. Finally, 6 is where you'll deploy the model into real-world settings. Skipping or rushing any of these steps risks total model failure. Let's talk about one of the most important secrets behind reliable AI, how we split our data for training, validation, and testing. Imagine you're training for a big final exam. If you just memorize the practice questions and never see anything new, you'll likely freeze on the real test. Machine learning models are the same way. They need to learn patterns, not just memorize the answers. That's where these 3 data sets come into play. First is the training set. This is the main study material, about 60 to 70% of your data. This is what the AI uses to spot patterns and learn relationships, just like you'd drill flashcards before an exam. Next comes the validation set, usually 15 to 20%. Think of this as your practice quizzes. This data helps tune the model, making small adjustments to ensure it's not just good at the stuff it's seen before, but that it's understanding the material on a deeper level. And finally, the test set, also about 15 to 20%. This is the real final exam. Brand new, totally unseen questions. It's the ultimate test of whether your AI has truly learned or if it just memorized the practice. We reserve this set until the very end and only use it once to get an unbiased performance check. Why does all of this matter? The number one enemy here is something called overfitting. That's when the model memorizes the training data word for word, but falls apart when faced with anything new. By dividing the data this way, we make sure our models generalize and stay robust in the real world. So in summary, train to learn, validate to improve, and test to prove. This careful split is what transforms machine learning from a classroom genius to a reliable performer in the real world. Most business problems solved by ML fall into 2 categories. Classification assigns data to categories, like detecting fraud or classifying product reviews as positive or negative. Prediction or regression forecasts continuous values, like sales revenue, inventory needs, or time to equipment failure. Knowing which you need guides data preparation and choice of model. Let's look at some final examples where machine learning brings real value into everyday business. First, sales forecasting. Here, AI looks at historical patterns and market cycles to predict your future revenue. That means you can plan budgets, schedule staffing, and order inventory with confidence. Next, fraud detection. AI sifts through mountains of transactions in real time, spotting suspicious patterns and flagging threats long before a human could react. This reduces financial losses and builds deeper trust with your customers. Moving on to inventory management, AI models crunch sales trends, seasonal shifts, and even external factors to predict demand. The benefit is less waste, better stock allocation, and lower holding costs. Finally, there's customer service. AI routes tickets to the right people, predicts how long resolutions will take, and even anticipates customers' needs based on data. The end result is faster response times, a smoother experience, and happier customers. The bottom line, machine learning isn't just tech. It's a real advantage that solves classic business headaches every single day. The last quiz of the day. A manufacturer wants to predict the time until machine maintenance is due. Which ML technique is suitable? A. Classification, B. Clustering, C. Regression, or D. Reinforcement learning? The answer? C. Regression. Forecasting continuous values like time, or in this case, time until machine maintenance is due. Now, we focused the majority of the day on why ML is great, but ML isn't the answer to every problem. For example, if data is scarce, Rule-based systems or traditional analytics may outperform ML. Regulated sectors may require transparent, explainable decisions, where sometimes simpler approaches are more sufficient. Good leaders know when to use the right tool for the job. So, how do you get started? Well, the first part is really starting by auditing your data assets. What data do you currently collect? Is the data complete, accurate, and timely? Are data formats consistent? You really want to identify repetitive, rule based decisions, and those are what's ripe for automation. You want to start small, deliver value, and grow from there. So, the key takeaways from session 2. Machine learning comes in supervised, unsupervised, and reinforcement forms. Data quality is the critical foundation. Machine learning workflows ensure reliable, accurate models. Not all problems need ML. Match solutions to your challenges. And finally, begin with a thorough data and process audit. So, coming up in episode 3, the generative AI revolution. We'll explain how AI creates text, images, and code, how to make the most of these emerging tools, and the business impact they're driving. Things like ChatGPT and other generative AI will be the focus of the discussion. Thanks so much for joining episode 2 of the AI Bootcamp. If you find this helpful, please like, subscribe, and share. Drop your data or machine learning questions in the comments, and I'll be sure to answer them. See you next time for episode 3.